sure. That'll. I don't quite know what's going on Wednesday yet, so that's part of the problem.
Sorry.
It's okay. You don't have to be sorry about anything ever.
Did you get a haircut?
I did.
I like it. It's good.
Thank you. Yeah, Amy cuts my hair. She started doing it during the pandemic, and I was like, good enough for me. Let's just keep rolling with it.
I feel like a guy's haircut is unreasonably expensive.
Oh yeah.
And you guys have to get your haircut way more.
Well, some guys do.
That's true.
I get like
That's
4 haircuts a year tops. Yeah.
Well, I get a haircut once a year.
What?
And my mom cuts my hair. So
Oh.
maybe once every 6 months, maybe.
Damn, that's nice.
Sorry.
How often do you get one?
Well, I'm lazy, so it's like once every 4 months, but it should probably be once every 2 to 3. Because it gets too long and hurts.
But see, I also have a boring haircut and I don't dye my hair.
Yeah.
So there you go.
Yeah.
I'm lazy.
It's not lazy. It's just simple.
Yeah, I like it.
It's old school.
Yup.
Yeah, I've never cared a whole lot about stuff like that, so I have trouble with it. Oh God. Okay. Yeah, I threw up this morning. I was telling Kayla. Yeah, pretty
Yeah, it's
nice.
not-
Yeah, it was really nice.
It's not doing so hot.
Doing okay. Yeah, I feel like better than I thought I would, you know. But I think it was the time change, and then like drinking tea on an empty stomach.
Just
See,
overall.
I didn't want to miss you all, so
That's okay. We don't want to miss you either.
we only have 6 weeks left.
Don't say that.
Sorry, we have 1,000 weeks left. I do have my book with me. This is useless now. Is there anything going on? You just turned in stuff, so you don't have like any homework.
We have 2 problems that we're supposed to be looking
Yes,
at.
I wanted to look at those
And I
together.
think today we were going to talk about 7.3.
Correct.
Yes.
I read 7.3. I don't.
You had a similar reaction.
And I read it again, and still, I
Okay,
I don't know.
let's talk about it. All right,
I want
cool.
to tell you that I read it and I was like, I get it, but
No.
no.
Okay, cool. Let's actually start off with something simpler, and I guess it's in that section as well. So, all right, there is this. I realized one of our apps too, and you might want to have that up. The one from Bluffton, the Bluffton app is the one to go, and I now know that.
Bluffton.
Yeah, it's our app. It has Bluffton in the address. It doesn't say Bluffton anywhere in like the. It's the good one. It's the one we use that allows systems and polar coordinates and stuff like that. Yeah, I'm kind of spaced out.
Is that?
It's weird.
I think that's the one that we've been using. No.
It is. It's definitely. Yeah. It's
Okay.
the.
Okay.
Yeah. They allow polar systems, so check
Okay.
out, go to OD, go to the selection, and then check it out, polar systems,
Wow.
which is really cool.
Oh my gosh, these look so neat.
I know, they're like, I wanted to sit down and just play with it, because you could get some crazy looking stuff.
These are really weird. I like them. I found a spot that if you are in that area, you just get launched into nowhere.
Yeah, I just clicked on it.
Which is so like,
I clicked down here and it shot.
Oh
all
my
the way
God,
up
that's
there,
beautiful,
and then
though.
Did that.
wow.
Yeah.
Can I see how do the trajectories move? Do they do the hopping like that? Like
They're
click,
really thick.
click one. Yeah, I guess it's not showing us. I just kind of was curious, like how they move. Boy, those are sharp corners.
It's like Runga Kutta is just dying.
Yeah, try the adaptive. There's like one more method that's like adaptive.
The switching.
The switching method, I think, is probably optimal under the arcade. Yeah, right there.
These are fast.
Yeah, I'll just add that. It's an option, I guess. It changes step size and stuff when things get weird. So that's beautiful.
Except,
It's
like,
very cool.
this little region, wait, hold on. Why did that one just, see this? It just launched into nowhere.
Yeah, that's kind of fucked up.
I wanna know, who are you? What is happening right there? I wanna know. Because if you move just the tiniest little bit.
Yeah.
So that, I think when I was reading it, it kind of felt like we've come upon a new tau versus delta table, because it was like this hyperbolic, you could be
Ooh.
a, what did we call, you could be a limit cycle,
Yeah.
or you could be a stable point.
Yeah. Yes.
And I think that's where I got confused, because I thought that it said that you can't have any fixed points inside of R, but then in the very first example, there's a fixed point inside of R.
Let's talk about it. Let's talk about it. Okay, cool. So the key thing is you actually remove the fixed point from your region. So let's look at this thing. Could you actually plot this one on the polar and use the A here? I tried this morning. It worked out just fine. And you have to use the @ sign. If you use the @ sign for theta, everything works out pretty good.
Oh,
Yeah, is it working?
I think so.
And then let A
Oh,
be,
they're so pretty.
let A, set the range on A so that it can go from at least maybe -2 to +2. I think it defaults to a positive range. I might be wrong on that.
Okay,
This
this
is not a fix.
is so funny.
Fix it. It's not.
It's not working.
It's not. Oh, why did I put? Oh, because I put an @
Oh,
and
there
I
you
changed
go.
it to theta.
Try that. Take out the times sign maybe.
Cut.
The asterisks.
But I took.
Oh.
It wasn't working.
It's not working. Why is yours not working? Put spaces in maybe. It's the stupid like that. Yeah, and especially between the multiplications. And oh, take those parens out. I think that's it. Never had trouble.
I promise.
The frickin'
It's
parentheses.
not the parentheses.
Oh. Try cosine of theta. Put parens around the theta. See if that helps. There we go.
That is not a happy Trinity over there.
Alright.
I'm so.
Irritated by Bluffton University. Where is Bluffton University?
I don't know. We're gonna go tell them off.
This
I'm
is
so emotionally, physically, mentally exhausted.
Yeah. And this just pushed you over the edge. Space portrait. That's what did it.
I watched the finale last night, and then I literally just sat in bed for 2 hours, just like staring into space.
Wow.
Because I knew it was gonna happen, but still.
You didn't go play the game, like just.
I'm working on it, but I know all of the plot points in part 1. I'm
right.
trying to avoid most spoilers from part 2, but I know of big things that happen in part 2.
There's some DLC you should get too.
I know it's built in. I have left.
Oh, is it? Okay, awesome.
In my copy of part 1, Left Behind is built in.
It's got the deal. Okay, beautiful.
So I'm working on it. I'm on the build chapter already in the game. So,
Very good.
but I was like, I'm not gonna finish this anywhere close.
Yeah.
Because I want to take time with the game, so I wasn't gonna rush through it to finish it before the show finished. But
Oh, yeah. No, that's good. It'll take you forever. You won't be done before the semester's out, I would imagine.
no, I know.
So let's check this thing. So you see a limit cycle probably forming there.
I think so.
Yeah, so the idea behind the Poincaré-Bendixson theorem is that we want to get this trapping region. So if we suspect that we have a limit cycle like here, and in fact I think we do at r = 1, what we're going to do is produce a region that has a hole in the center. So a punctured region, really, and that's So that's it. So there is a fixed point here. You can see that when r equals 0, we definitely have a fixed point. I think it's an unstable spiral, moving in some direction. The other way, because theta dot is ticking positive, so it's
So then,
yeah. So what we're gonna do is find these two regions and just show that the flow is into that region, always. And once you have that, you've trapped whatever flow. But Kayla, yeah, in answer to your question is we remove the fixed point. And so we do that in the, he also does that in the example. So in the example you read, you've got like this unstable, I think it's an unstable spiral or something here. It's unstable nonetheless. So you end up creating this weird ass region, and I thought it was really cool. Maybe that was what was confusing. Like how did he get, or like what was the reasoning behind? I think this was like at B over A, maybe, or something like that. Yeah, so you've got this unstable spiral. The first thing he did was do a polygonal bound where we know that the flow is always in. And this was the tricky part here. Part of his argument was that as you move away from the origin, these things become diagonal. What are they when we move a little bit this way? And they turn out to be steeper than diagonal. So if we draw a diagonal line down this way, which is what he did, just construct the equation of that line, then these have to be moving into that region on that edge. So does that make sense? So like he looked out here and he's like, things are essentially parallel as we head toward infinity. So what are they inside here? And they turn out to have a slope that is less than -1. And he looks at y dot over x dot. And so that means all the flow arrows here have to flow into the region on a perfect diagonal. And then down here, I think these are just straight up. And he does something, actually there's one little like region down here too, right? Where he cuts it off because we know the flow is inward there. It's pretty complicated, there's a lot of detail in it. But that's his basic plan, is to just simply kind of suss through what boundaries are gonna give me an interior flow. And then in here, since we know this is an unstable point, we can just find a circle around it where the flow is outward. So we just puncture it there, and this becomes our region, everything except that hole around the fixed point.
So I understand that we're trying, okay, in order that it be a limit cycle, it has to follow clockwise or counterclockwise.
Correct.
And that, I understand that part. I think I'm confused on how those like boundaries are determined from the two curves. Does that make sense?
Yeah,
Because I see like the curve that's this one, like the super steep and low, like that's where we're getting this, like
oh yeah, you got a
this
picture right
parallel,
there. Yeah.
that, or it's not parallel, but it's close. And then I'm not, do you see what I'm saying? I don't understand.
You don't understand, like, just the basic process, right? Is that what you're saying?
Unless it's a process that we've done before. And
It
I'm
is
just
not a
not
process
getting it.
we've done before ever.
Great, okay, because I'm like, I don't know what we're doing.
Yeah, okay, well, let's take a look at a few of the boundaries. So like,
Am I alone? Do you get it? Who's to say? Who's to say? Okay. That was.
it's a good answer. I'm gonna start using that.
Do you get it? Who knows? Do I?
Can anyone really say
That they know.
that they know
Probably not.
in this uncertain world, in these crazy times? So let's see, what was the original system? I just gotta get that. It was, where the fuck is it? well, hold on. So actually, let's just go back to this and then we'll come to that one.
Yeah, sorry.
So, no, it's okay. So on this one, it's really easy. Did this example make sense
Yes.
in the book? Yeah.
I
The-
understand this one.
Yeah, because you've just got these bounds, easy bounds on cosine, that it's between -1 and 1, so you can replace this with with a 1 out here and have an upper bound on r dot. And then you can replace it with -1 and have a lower bound on this r dot formula. That all made sense. And then you just get a couple of circles where you've got the flow inward on both of those circles. So this one, I guess we're cool with.
Yeah.
Okay, great. So that's like the archetype, and nothing would ever work out that pretty, ever. But it gives us a sense of what he's up to with this. So then, let me get the equations. Where the hell actually are those equations? Let's see. Oh, here they are. It is x dot. I don't think Sydney's making it. I think she was probably like, you know what?
No, she wouldn't have texted me if
Oh.
she, but I did lie. I thought it said that she was running. I thought she said she woke up late, she'll be here in 5 minutes, but it was, she woke up 5 minutes ago, she'll be late.
It's very different.
So, cause
So-
I also only woke up like 15 minutes before class.
But you're a pro at it.
Yeah, but I also live. over
Yeah,
here.
that's also true.
So-
Yeah, she's like in an apartment somewhere, right?
I think so.
Yeah.
So, yeah, that's not bad.
That's not bad. That's not bad.
That's on me, sorry.
It's okay, cool. So let's take it, it's all good. You're simply attempting to bear information for us. You did your best. Okay, so let's see, let me just go through here real quick. So some things are pretty easy to tell here in terms of the boundary. How would you know that this was inflow here on this axis? What would you do to know that all along the the y-axis, we had an inward flow, at least up to b over a? How could we discern that?
Oh, take one of the curves and subtract the other.
Oh, you're getting fancy, way too fancy. That's good though.
Well, that's what we did a long time ago, right? Like,
Yes.
We're like, okay, the top curve minus the bottom curve is a positive number, so it must be positive flow. Does that make sense?
It does, and I think that he does that here.
Okay.
But I don't think we need that here. I think some parts of this are a lot simpler than others.
Okay.
So that's all I'm saying, Kayla.
Okay.
So like here, when x equals 0 on this, so along x equals 0, we've got x dot equals ay. And since y is positive and a is positive, that's a positive flow. And then we have y dot equals what? Does that actually turn into b minus ay? And that's gonna be positive as long as y is less than b over a. Does that make sense? So this will be positive when y is less than b over a, because then we're subtracting something less than b. B and a are both positive numbers, so we're cool with that. So that's like that part of it. And then when y equals 0, but then that changes, right? That actually changes right as you move over that point. Then the flow actually becomes left facing after that point. And then when y equals 0, what do we got here? We got x dot equals negative x, and y dot equals, did I get that right? Yeah. B. So let's think about that. So now I'm on the bottom axis. This is all that I care about down there, because that says that y dot is positive along the entire horizontal axis. X is gonna move, it's gonna be pointing a little leftward when x is positive, and a little rightward when x is negative, but it's still got a vertical component, a positive vertical component. Does that make sense? We'll just kind of like go through each little
Yeah.
nibble at a time. Yeah.
Yeah, okay.
All right. Cool. And then on this line out here, this is where I think he takes a look at the difference between y dot and x dot. So the first thing he kind of notes is that when x and y are really large, the only thing that matters are those quadratic terms, are those are cubics, right? So when x and y are really big, because this is squared and then times the y, it just annihilates these. When x is 1,000, y is 1,000. You're sleepy too.
Yep.
I almost was gonna like email you all and go, can we just like start late today? Probably should have. Good morning. I'm just talking about how I should have started late today.
Yeah.
Yeah. All right, so that when x is really big and y is really big, and we'll just give you time to wake up, Sydney. We get x dot is approximately x squared y, and y dot is approximately negative x squared y, so that the ratio of those two is approximately -1. Wait, does that make any sense?
Yeah, that makes a lot of sense.
Okay, awesome. Yeah, it's cool. You probably did understand this and it just got like a little jumbled. So that means when we're out here, you know.
And because, okay, so we're thinking more about trajectories, not the actual line. So because it's
Yes.
parallel to the outer trajectories, that's why we find, okay.
That's it. So
Okay.
that was his motivation. He's like, way out here things are parallel. Let's pick a line that's perfectly diagonal. And we're not going to be perfectly on that. We'll be on one side of it or another. And so then in here, I think we take a look at y dot minus x dot along this line. Actually, here, let's compute this quantity. So that's going to be b minus. Isn't that what he does? He does do y dot minus x dot, I think.
He does.
X dot minus y dot, actually. X dot minus negative y
X
dot.
dot plus y dot.
X dot y plus y dot. Oh, yeah. Well, that definitely looks better because then shit cancels.
You're like, this isn't gonna work.
Yeah,
out,
I was
guys.
like unhappy with the way that was going. So that's gonna be b minus x, and that's it. So, right, when I add these two equations, these cancel, and I just get b minus x.
And that gives the -1, and we're starting at b.
Yeah, so when x is bigger than b, y dot plus x dot is a negative number. So in other words, y dot is less than x dot.
Yes.
Yes.
So,
Yeah, or negative x dot, sorry.
so looking at our little diagram, friend, why is it b and not b over a? I know that we don't start at b over a.
Why is this?
Like, I understand from the.
You're like, it all came together while you're, okay, awesome.
I have to read all the things, not
You
just
just-
the things that.
All the things,
Yeah.
it's all good. Everyone's got like infinite slack this morning.
Oh,
So we'll just
yay.
take it, just enjoy it.
Nice.
Yeah. Hey, I woke up puking. You know, I decided I'm coming in. You too?
At 3 a.m. this morning, yeah.
Really?
Oh.
Yeah, I drank a bunch of tea on an empty stomach and then was like, I'm gonna go outside and vomit. That's my new thing. I like to go out in the backyard, nice and cool and refreshing.
Fresh air.
Yeah, and you can just
yeah.
puke like with abandon.
Uh-huh.
Well, and then when you finish.
Good job recording.
Yay!
Well, then when you're done, you can lay in the grass and it's cold.
It is. Yes.
Yeah. because-
Absolutely.
I
Yeah.
get really, really cold. Like, I had the chills at 3
I
a.m.
hope
this
you're
morning.
not. Wait, you're feeling better though.
Oh, no, I'm fine. I just didn't sleep very much. Because I was like, huh. No, yeah, I'm fine. was really like, why am I went to bed an hour and a half ago and I was fine.
That's pretty weird.
Yeah.
Did you eat something weird before bed?
Before bed, no, I ate dinner. I ate lunch/dinner at like 6 when I got home from work, and then I was fine. And then my body just said, nah.
Did you get too hot when you were sleeping?
I don't know.
Does that happen to anybody else?
Yes.
If I get
Sometimes,
too
yeah.
hot, I'm like, ooh.
Oh.
There's a problem.
She said, ooh.
So, not good.
All right, back to okay.
Yeah.
So this is true. If X is bigger than B, then this is true. Then this is true. Then this is true. And this means that the Y slope is more negative than the X slope. Does that make sense? And you can even just like kind of cheese this out, get rid of the T's, and you just see that the solution slope is less steeper than -1. When X is bigger than B, so that's why there's this cutoff at X equals B. So that's why he made that seemingly arbitrary cut right there. The minute X is bigger than B, these slopes are steeper than diagonal. Does that sound right? Yeah, it's not bad. And then let's do one more. Kind of all these are reasoned like that, so I think we understand all of them, except there's a couple. When Y equals B over A, what do these look like? We've got, I'm kind of curious myself what that one turns into. So we're gonna get negative X plus B plus X squared B over A, and then Y dot is equal to B minus B. Oh, that's cool. That's fun. Minus X squared B over A. Yeah, so that's all handy and happy, because this is always positive, right? And then this is negative. And this cancels. So that tells me that Y dot is negative, and X dot will, who gives a shit, really? Doesn't matter. But here we have Y dot is less than 0, so we're pointing downward, Kayla, and that's really the key thing there. Does that help?
Yes.
And Trinity, you buy that?
Yeah.
Cool. Thank you. And Sydney, you probably buy that. Future you will buy that at some point.
Future me will buy that after I watch the first half hour of class.
Yeah. Well, I don't think you missed a whole lot.
Oh.
We've been moving pretty fucking slow.
Cool.
So.
We're going at turtle speed today.
Yes, absolutely.
Happy Monday, friends.
So then check this out. When X is less than B, this is a positive quantity as well, so the whole thing's positive. So all along that top little slice, slopes are kind of like that. Downward and inward.
Thank you.
Does that all make sense then?
Yes.
Okay.
I only have one more question from
Yeah.
the example that I think really confused me. What is this random ass arrow in the middle of our limit circle?
Where?
This one right here. This flow makes sense. Is this implying that it's like spiral?
Yes, let's talk.
Okay.
Yes, so those are part of the isoclines.
Random ass. God damn it, Kayla.
Sorry.
I love it here.
I mean, maybe it's not random, but.
It's not random, actually.
Shocker.
But,
This textbook that he worked really hard on didn't have a random.
random
accent.
ass.
Yeah.
Yeah.
That's purpose.
So when you said, you got like, oh no, shit, no, I totally.
It's x
Thank you.
equals minus x plus ay plus x squared y. Y dot is equal to b minus ay minus x squared y.
Thank you.
Yep.
Cool. So, the isoclines are the places where either x dot is 0 and you have solely vertical change, or y dot is 0 and you have solely horizontal change. So on that line right there, that is the isocline for no horizontal change. So if you set x dot equal to 0, then you're going to get negative x plus ay plus x squared y equals 0. And you can solve this for y kind of nicely, actually. You get y equals, x over a plus x squared.
But that's this.
Yes, that is this curve right here.
Yes.
Yes, and along this, let's see. So the y dot is positive here. What is this? Let's see, where do these two intersect? They kind of intersect. And then here's the other isocline, like that. And those intersect somewhere. Let's see, where do those intersect? So the other curve is y equals b over a plus x squared. So it looks like they intersect when x equals b. So right, yeah, so this point right here is x equals b, which makes sense because that was this thing at the top here, right?
Yeah. Okay.
Yeah.
That. Yes.
Yes, it's all
Yes.
kind of coming together. And then in this thing, when x is less than b, I don't know, we could figure it out, but the slope here is positive, purely vertical up, and then over here it's purely vertical down. And then here I imagine it's like this, and here it's like this. And so you get the sense of a swirl. Is it
Okay,
neat?
so
Yes.
isocline and a nullcline the same thing then?
Sorry, I should have called them nullclines.
Okay,
Because a nullcline means one component is 0.
okay.
And
That's
the
what I
iso
thought.
means all the slopes are they are isoclines, but they're specific isoclines. They're
Okay.
the nullcline.
Because the
Okay.
isoclines are like those way over there. And
Yeah.
the ether.
Yeah.
Okay.
Yeah, any line where the slope is constant along that line is an isocline. I think just iso is all the same, right? Same slope. Cool. So does that make that all feel a little bit more grokked?
Yes. Thank you
That's
for.
a good one.
Yeah, what was that?
I like that one.
What's
A
that?
little more what?
Rock.
Grokked. You never heard that word?
Well, no.
Well, no, we're not 1,000.
Oh.
Grok.
Okay.
Yeah, it's a good word. Do you grok? Yeah,
Can I have
grok.
a definition?
Yeah,
Yeah,
like
yeah.
just comprende. You get it.
Yeah. Okay.
Yeah.
Okay.
I think.
These
Let's
are
look it
all
up.
kinds of languages here.
Let's look it up.
Is this like really old English? Is Greek?
Not that old. I mean,
Oh.
my old.
We live very different lives, Dr. T.
Yes, you live very sheltered lives.
He really.
I
said.
concur.
To understand intuitively or by empathy. To empathize or communicate sympathetically. To establish a rapport.
Dang. I've never heard that word.
It was invented or coined in the 1960s.
There you go.
You've
Damn.
been with me today.
Wow.
So now you can toss that out.
So that everyone around us can have the same reaction that we just had.
Oh
You're like,
absolutely.
What did you just say to me?
People think that you're being mean.
Rude and
No, I'm
offensive.
just saying
No.
I get it.
I
No.
said grok. You get all
Did I
aggressive.
stutter?
It's like capiche.
Yeah.
It's like capiche.
You could really, if you
It's
say
like
capiche
capiche.
aggressive enough, it all of a sudden becomes intimidating.
I had an orchestra professor do that to me, or orchestra teacher in middle school and high school do that to me. He would say capiche to us, and we had to say capoche back.
Wow.
And it was very aggressive. And
I
he'd
like
get mad if we
capoche.
didn't say
It wasn't.
capoche
It
back.
wasn't in fun. There was no light.
Oh.
This
No.
was.
It was like a disciplinary thing.
Oh shit.
Where it was like if we were like being too loud or not paying attention, he'd go capiche, and we'd have to say it back as if we were like
Like you're in the
6 years old.
military.
Or yeah.
Like, hey.
Yeah.
Capiche.
Gosh.
Gee, sorry.
Capoche.
Yes.
Oh my
That was
goodness.
weird. I hope he's doing well.
I
I hope
feel
he's
like
okay.
so
some
too.
of the like hardest people I've ever met are orchestra professors. I
They're
don't know what it is. Because I'm like, you guys play such gorgeous, beautiful music. Like, it's okay. We can take a deep breath. Like, it's all good. No.
They don't breathe.
It's terrifying.
There is
No.
no. Yeah, they don't breathe. That's a good
Uh-uh.
point. Just no breathing. So,
You breathe wrong.
There's a
and
lot
you're
of there's a lot of weirdos that end up in that role too. I think.
the orchestra teacher
No
at my
offense,
high school
Trinity.
was
You were
named
in that world
Dr.
at once.
Mr.
You're not
Raver.
weirdo.
Like, that was
No,
his
I'm still in that
legitimate
world. Don't worry about
name.
it.
Oh.
I play in the orchestra here.
Yeah, which is really unfortunate. But he was
Yes.
also scary.
Yeah. Yeah. Our guy was kind of a douchebag.
I think that can come with the trade.
And
Unfortunately.
this is kind of a gross story. And I hope it's not too inappropriate. But I was like, when I was at grad school, I was dating a woman who, she wasn't in high school.
Okay.
She graduated high school, but she was still like involved with her band leader, who started dating her in high school while she was in high school. It is fucked up. It is like, this guy should have been in prison.
Yeah.
Like, he had all sorts of weird S&M-y things. Creepy. Like, it's scary. Like, yeah, he should have been he should have been in prison.
Oh my goodness.
You know?
Was she okay?
Yeah, I guess.
To the best of your
I mean,
knowledge.
how can you be? I don't think you really are, even if you think you are, you know? Because that's criminal.
Well, and that's like a really vulnerable time.
Yes.
Like, I don't think I've
Extremely.
ever met a high school girl who's like solid. You know what I mean?
Oh God, no.
Like,
Anyone in high school, like the girls are probably more solid than the guys, maybe.
Barely.
But barely.
I think there's different ways that
Yeah.
yeah, I was gonna
high
say.
school affects
Yeah.
people.
I wasn't like okay till I was like 40. I was like,
You're like, I've
okay,
been
I'm
out of high
starting to
school
get
for
it.
more
I
than
think-
20 years.
I think I understand something.
Dr. T's like, I'm gonna be completely honest here. Listen, 40.
I'm
minimum.
still figuring shit out every day, you know?
But can you imagine if you had it all figured out? Like, life would be so boring.
Oh, yeah.
So I don't want to have it figured out.
No, that would be
I don't know
boring.
that I want to like
Ew.
keep the high school vibes. I'm okay with
It,
yeah,
In the past.
yeah.
I'm out of
Yeah.
those are done.
having things
Never
figured out
again.
might cut back on a few mental breakdowns. Do you want to come to class? You can come in. You can come in and sit with us.
Hi, I have a question.
Yes,
So this
is a class that's running right now, just so you know.
Yeah, they invited me to come in.
Yeah,
Okay, all right.
it's fine, Dr. T.
I have a
Really.
question. Okay. So this says there are 3 exams and a final for calc.
Jesus.
Yeah,
Yeah.
there's 2 exams and a final.
Yeah. Okay. The syllabus says 3,
Oh, okay.
and the second one's being handed out today,
Correct,
and it's due Wednesday,
correct.
and that's all there is.
It's not due Wednesday, it's due Friday.
It's due Friday, and there's a write-up too.
Mm-hmm.
Okay, cool. I just want to make sure. I was like freaking out. Like, did I miss an exam?
You did not miss an exam.
That-
You
that
missed
was why
a lot
that-
of
that
class,
warranted
but you have
coming
not
here.
missed an
He
exam.
misses
Yes,
his
yes.
class, but he shows
Thank
up to
you.
ours.
Yeah. Yeah, he's showed up here more than that.
It's the way that he goes, they invited me.
I know.
I said,
Sir?
It's like, okay.
Yes.
That's just because Sydney's really nice. And
Yes.
So Sydney
like,
would
you know
invite
what?
anyone.
I really was like, maybe he just wants to learn with us, because he's in here a lot.
Maybe so. We'll close this fucking door.
And then he goes, I have a question. I'm like,
It's like, well, that's not what that invitation was.
well, sir.
Yeah, right?
Unless you're
We were mid-conversation, thank you
Yeah.
very much.
Uh-huh,
Unless
yeah.
we
we
need
have
a
a
more
more
discussion.
question in regards to point
Yeah,
theorem.
no shit. Yeah, he got into med school, so I think he just is
Jesus.
like, just saying fuck it to most things.
He's a senior?
Yeah.
Oh, that I
I
would
know.
not have guessed
Yeah.
that.
I would not have guessed.
I
Oh,
have
no,
no
I was
idea
freshman.
what we've
I mean,
been.
Yeah.
I was saying freshman.
college.
Right, with just the,
I
like,
would've
showing
said
up here like
Freshman or sophomore.
yeah.
Yeah.
That actually kind of fits going medical school though.
Yeah.
That seems about right. Command the room.
Yeah.
That's why I'm out here. I'm like, people look at me and they're like, yo, you're gonna be a doctor?
Absolutely not. No,
That
sir.
sounds exhausting.
What about
that
me
sounds
gives
horrible.
doctor vibes? Okay, no.
No.
I like that. Are you gonna be a math teacher? What? No. Do I look like a math teacher to you? No offense, Dr. T.
It's okay. None taken. Do I look like a math teacher?
Yeah.
Well, maybe.
Well, yeah. But then again,
Oh, wait, I recognize that one. What's that?
Hey,
What,
oh,
X's and Y's?
oh,
Is that what we did for homework?
no, yes.
What?
This is, did you start working on it already?
I finished this one.
You did?
Oh my
I didn't
gosh,
know how to do
she's
the other one,
incredible.
But I
Oh,
finished this
wow, okay, damn, nice. And so you did
It's
the
because I thought
polar,
it was due today.
and you did the polar coordinate change and everything
Yeah.
successfully?
Oh, Trinity.
Yeah, I spent too much time on it because I thought it was due today.
Wow, nice. Well, I kind of want to go through it for
That's
everybody, if
fine.
that's cool.
That is
Or at least
perfect.
talk about how to
Yeah,
approach it,
that's
because there was
cool.
this and then 733.
Yeah, that one I was like.
Okay, we'll take a look at that one too.
Okay, yeah.
So this one here, classify the fixed point of the origin. That you should be able to do. That should like be a no-brainer.
Yay.
Yeah.
Okay.
So get your Jacobian, do all that. And they even tell you it's at the origin, the point they want, so
Oh, how nice of them.
pretty freaking minimal effort required there. And then they ask you to do a change of coordinates to a polar system. Because as we've seen, that's kind of an easier place to see those limit cycles happening. So that's the goal. Let me tell you how he got those equations. So he gives you like the change of variables. But let's talk about how to do it. The first one is when we do polar coordinates, we have this relationship first.
Sure do.
Yeah. Okay. Wow. That's very,
Yes.
very affirmative.
I know
like
these
it.
things. These things I sometimes know.
You got it. And then what's the other one?
Is it R?
I got you.
It's
Yes.
there's a theta.
Theta equals inverse tan. Y right.
Nice.
I didn't
Oh,
even
yeah,
use
yeah.
that
It
one.
was all. It was all there. It was all.
I didn't even use that one.
Yeah. That's a. You did. Yeah. I
didn't
guess.
use it.
Hmm.
I didn't use
We are a third of a whole.
Yeah. I guess you really don't need it for like the yeah. So then differentiate these with respect to t. So if you take this and we do a ddt.
Okay.
2r dot, that's the chain rule, right? So it's 2r times the derivative of r with respect to t
Uh-huh.
Yes.
equals 2x dot plus 2y dot.
That makes so
Plus
much
dots.
sense.
Doesn't that make sense?
Um,
And so the actual equation, then you just divide through by 2 and you get that r dot equals x dot.
Why are there so many
Oh.
dots?
Y dot. So that's neat.
I'm not sure if the derivative.
Then this one here, we do the same thing, we do a ddt. What's the derivative of that?
I don't remember.
Of inverse unity?
What's,
It's like some weird
Ooh,
ass.
isn't it cupsy?
what's
I
that
thought it-
formula?
It could be.
I used to have flashcards.
I remember when I had these
The
memorized.
flashcards can't help you now.
The flashcards.
Not a
I
whole
still
lot
have them in my
can.
dorm though. Yeah.
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 So then
Oh,
this,
I know it's some weird ass.
yeah, this becomes ddt of y over x.
Whoopsie.
This is the chain rule I'm doing right now. And then the top, how do I do the top?
Equals. Oh wait, no, I'm still.
Oh.
How do I find the top?
Negative y over x squared.
No.
Is that dt?
That is dt, thanks,
Okay.
sorry,
Oh,
yes.
okay.
It should
Caleb
be
was like,
DDT.
"Excuse
Yes,
you."
that
I was
would-
like, I feel
oh,
pretty
yeah,
confident
yeah,
that
you
is
would,
what that is.
you would be totally right with what, yes. So
Okay,
just,
so we're gonna use the quotient.
yes,
Okay.
so y dot x minus yx dot
Caleb's gonna start a riot.
squared
I was
over.
just concerned.
Wait, no, I'm
So
almost
it's like-
sure.
I feel pretty confident that I have found at least more than one derivative.
You are, yes, ma'am. So top and bottom, multiply by x squared.
So true.
And what's the bottom?
I swear.
Yay! And that's how he got his formula.
Jesus. Weird.
That's cool.
Fun, funky, fresh.
So then,
I'm sorry. It overcame me.
it's all good. It's completely cool. So then this can be replaced with, oh wait, we have to kind of work this into the R and X form. What did you do? I'm curious, Trinity.
I took the R dot form and plugged in our X dots and Y dots and simplified from there.
When you say, did you like combine these first and then do that, or?
No, I literally just plugged in X dot where it says X dot and plugged in Y dot where it says Y dot in the R dot
I
equation.
can see.
Yeah.
Dr. T says, wait a minute.
Thank you.
That's all I did. And then I just simplified based off of our other understanding.
Oh, I see what you did. Oh, okay, that's neat. Okay, that's really cool. So
Good job,
Trinity took literally what you were saying.
Yeah.
It was just like took this and took, oh, so it's X times and then
I
X
really
dot.
didn't know where to start, so I just kind of started
You're like,
somewhere
what
and then
happened?
stumbled through and I went, this is fine.
This is
This is a
Like
good
for me.
enough answer.
This is fun. I kind of want to write it out just because
It's a fun little one to write out.
it is neat little algebra. You see what's going on here?
Substitution.
Ladies?
Oh, yes, I got you.
Okay.
I'm a couple steps behind.
And then just simplify that, and I guess things work out. Hell, let's just fucking do it, because I'm not good. I want to see. So x squared minus x squared minus x squared. Maybe we'll leave the other one. And then lots of good, they're hopefully good canceled.
Good God, there's a lot of X's and Y's. Yeah.
Not quite as much as you'd hope.
Get out of there.
That's the method.
That's it, that's it, yeah, so, I guess we could pull an x squared, I don't know if that helps, I'm just gonna do it, I could pull an x squared out of these two, and I've got 1 minus x squared minus 5y squared. I'm just looking, this may or may not do anything useful.
Okay.
Probably not, actually, now that I think of it, I don't see how that's gonna help. This is r squared, so that's helpful.
Yay.
So this piece actually becomes y squared times 1 minus r squared. That's not bad.
I don't hate that.
That's good. And oh, and look in here. We could write this as x squared times 1 minus x squared minus y squared minus 4y squared plus y squared. So here I just like pulled one of those off, because then I saw that that's another 1 minus r squared there. I don't think it's not helping a lot though. Did you end up with something pretty at the end, or not really particularly pretty?
It's okay.
Yeah.
Like it's not the worst thing I've seen. But I took a different route in terms of simplifying.
Okay, we'll check in a second. I just want to finish this shit up.
Yeah.
So there's one of these times that, so you could pull the 1 minus r squared out, have it times x squared plus y squared
If you must.
minus 4x squared y squared. Hey, that's not bad. And so that's r squared. And then here, you could just replace, use the polar subs. Maybe this is what you did then next, Trinity, I'm not sure.
Oh, I remember those.
Yeah, you could use those, and then this becomes 1 minus 4. Each of these will get an r squared, so that's an r to the 4th. This could be kind of cool. And then you get a cos squared sine squared. Did you get anything like that?
Mm-hmm.
Oh, cool. Awesome.
But I simplified it one more step.
You did one more step. What'd you do next?
I got rid of the cos squared sine squared with, there's some sort of relationship on it. It's,
Did you use a double angle formula?
I think that's what it's called.
Did you go to sine of 2 theta?
Yeah.
Okay. Yeah, so you could rewrite that as, I like that. And then, oh, then you borrow the 2, so this,
Mhm.
yeah. Yeah, cool. And then this would be like a negative, I don't see much else cool happening here. It doesn't seem like much else goodness could come our way.
You can just rearrange it a little.
like you see if we can gain any insights that way. So here you could, this is an r to the fourth, but so it's r squared minus r to the fourth times 1 plus, ooh, that's actually somewhat interesting. Because then this is always bigger than or equal to 1. That's not bad. That's not freaking bad. Does that all look reasonable?
I love when things that look like that turn into things that look like that.
Yeah, it's really pretty. Let's, yes, go ahead,
So,
please,
okay,
please,
let's
let's
get in there.
talk, let's
I'm
talk.
not trying to be obtuse. When you go from in x's and y's and then you sub the polar, yes?
From here to here?
Yes, sir.
Yes.
So where it goes 1 minus r squared quantity, x squared minus y squared quantity, why does that reduce to 1 minus r squared times r squared?
Because x squared plus y squared is r squared.
There you go.
That was not supposed to sound like condescending or
Thank
anything.
you.
No, so sorry.
No, that
You-
is,
you
that should be
never- you never
condescending.
sound-
I can't be this far in my degree and be like, it's up there like 5 times, and apparently that one time it was not.
It's all good.
It happens.
Thanks.
Yes, ma'am.
Second line of the simplifying. Okay, at the end, where, okay, so yes, that turns into y squared, the x squared plus y squared, but why does that then turn into y squared?
Because there was this, so this right here was y squared minus y squared r squared, and then I pulled the y squared out.
Okay,
Yeah?
Yeah.
Cool.
I buy that.
And I'm gonna totally cop out and ask Trinity what you got for, let's see, so that's, wait a minute.
You have to,
Yeah, I'm not done, am I?
you just have to divide through by an or.
Oh, yeah, because this was r dot equals this, right?
But yeah,
Yes.
other than that, it's.
Yeah, cool, so r dot equals r minus r cubed, 1 plus sine squared, 2 theta. Yeah. That's neat. That's neat. And I think there's actually another way to see that is that it's this, kind of this classic thing here. But then you also have this super high term out here, just kind of fucking things up. They're both, I think they're both useful, actually. What did you get for theta dot?
I'm gonna be honest, I didn't do that.
Oh, let's do it. Yay! We got something to do together. Let's all do it together.
Together.
Let's get theta
I'm
dot
not being
together.
honest, I didn't do
Well, because I didn't need it for C or D after that.
Teresa,
You didn't?
I
Really?
just didn't, cause it relies on the relationship or the value of R dot,
Oh, you're right.
so I didn't do it.
Okay, well then let's not mess with it. But it would be cool if everybody could give it a shot. What's that?
Okay. I'll-
Yeah, let's give it a shot, because,
Okay.
and then we can kind of move on to the next one with our last 15 minutes. Let's see, so after we do this, let's actually address the rest. So yeah, you really only need that R dot equation for C and D. Oh, well then this actually makes that pretty easy, I think, at this point. And you want to find an R not value so that this stuff is always positive. So find R dot, R not, such that R dot equals, why am I rewriting it? Such that this is greater than 0 when, so this will be our inner, let's call it R inner, when R is greater than that R inner.
And this is C.
Yes,
Okay.
yes. And that will take some experimentation, but check this out. Actually, here's the tip. This form right here is gonna help because this thing here, this is positive or 0. R is always assumed to be a positive number, so this is actually greater than or equal to R minus R cubed, minus R cubed. and it is less than or equal to, I guess just r minus r cubed, because you're taking away something there. And so you can use these two quantities to help answer that question up there. Do you see where these are coming from? Sydney? Kayla? Like why this thing here is always greater than or equal to this, and always less than or equal to this.
I get why why the last one is less than the other one, but that first part, why is that greater than?
Because sine is always bounded, sine is less than 1, less than or equal to 1. So the most this could be, most this could be is 1. And so if we set it to its maximum, that's the smallest this side can be because we're subtracting it.
Okay.
Does that make sense?
Yeah.
Cool. And then, yeah, you can,
So then,
yes.
if it can't be -1 because
Because it gets squared.
shit. Okay.
Because I ran into that too.
Does that make sense?
I think so.
And then look for an r, so you've got r minus 2r squared, r cubed. When is this positive? Right? Find an r when that is positive. And then find an r when this is negative. And that'll give you your two bounds. Like this one here, I think clearly if r is bigger than 1,
Yeah.
that quantity is negative. I'm not quite sure what it is here, but it's pretty, probably r is between 0 and like cube root to square root of 2 or some shit like that, or cube root of 2. What'd you get?
It's more 1 over the square root of 2.
1 over square root, that's what I meant, yeah, 1 over square root. Let's take a look at then the other one. That was 733, this is the one Trinity has not done yet. Is it cause you just like looked at it and you didn't have time because you were thinking it was due today, is that what?
No, I was like, he's not gonna like make it due today, but I looked at periodic solution and tried to look through the book to see where that came up, and it didn't make sense to me, so.
Oh, okay. So what we need to do here is just find the existence of a limit cycle. So that's what we're doing here. We're trying to trap in a limit cycle.
Okay.
And then we'll have a periodic solution. So we're gonna use the Poincare-Bendixson again.
Pronounce
You
it
say
again.
that so nicely.
Oh, Poincare-Bendixson.
I knew it wasn't just
I'm
point
just
care
gonna call it P.
because like that's what it looks like.
You say it so nicely.
Oh, thanks. Yeah, I'm very continental.
He's an international man.
I truly
A man of culture.
Yeah. I went to Florida once.
That's
all
everything
you
you
need
need to
to
know.
know.
Oh, yeah, I'm giving-
That's enough.
Went to New Orleans with Cybert once
No.
Wait.
Oh, sorry.
for a conference, for a
Yeah.
math conference.
Okay, I was like, you
I've
guys
been to
just
New
hopped in a
Orleans with Dr.
plane.
Gray before.
Did you?
Yeah,
Oh, wow.
Was that wild?
in October. No, what was
I doubt
more
that was
wild.
wild.
No, what was more wild was having to be in an Airbnb with him over the summer in Illinois, 2 summers ago, because we were at Fermilab doing our cute little research, and it was still during COVID, so there wasn't the housing on Fermilab site wasn't open, so we had to get an Airbnb.
You
So-
shared one together?
Yeah, so I played house with Dr. Gray and 2 other students.
Wow. Wow.
Buddies.
That's weird.
For how long? A week?
Okay, it was, at least it was only
It's
a
like
week.
a week and a half. Week and a half? I don't remember.
Dang.
It was, yeah. It was,
What's the unique experience you have over
Uh-huh.
most everybody in the
Yep.
school?
He's probably a decent roommate, I would imagine. Very respectful.
He was very respectful. He was nice. It was only a 3-bedroom, and there's 4 of us, so he just slept on the couch.
What a guy.
No one slept with Dr. Gray.
Well,
Like-
But he
That might
didn't
be
kick one of us to the couch.
Yeah, that's
That's so
He's-
sweet.
that sounds
Poor
like
guy.
yeah, very cool.
I don't even know which one Dr. Gray is.
I don't know how to
I don't know
describe
how to
it.
describe
I love
it.
Dr. Gray.
Is
I wish
he
I
in
had
your
him
guys'
for
office?
physics.
He's
Yeah.
in the physics and math.
Okay, towards your end or
Like
towards?
across from Duval, across the hall from.
Oh.
He's right next to Patna.
Yeah, right
too.
next to Pat.
Oh,
Just
I
to
know who
the
you're talking
right.
about.
He,
I have to go off of location.
Yeah.
I know whose office goes where.
Yeah.
Yeah, I know who you're talking about.
I feel like he's never sitting down.
Oh no, he is.
Sure, he's like,
He, well, I guess I always see him in the chemistry suite. Like,
Oh,
hey.
And I love that guy, but when he's sitting in his office and he's not doing anything, he kicks his shoes off. He's having a great time.
Yeah,
As
yeah,
he should.
yeah.
That's awesome.
As he should.
That's why you
It's
have an
chill.
office, so you get to like do your own thing.
And he works so he's just like his job is his life.
Yeah,
like
no, it is.
research is.
He constantly, he's never not working. You know,
Yeah.
it's either his job or his cats. And
Well, that's
all
cool.
he cares
Yeah,
about.
yeah.
Nice.
He has 2 cats named Cheeto and Oreo.
Yeah.
Nice.
Is one of them orange by chance? Is Cheeto orange?
I hope so.
Yeah. Good,
That'd
good.
be funny.
And I bet you can guess what color's Oreo.
I hope so, or else I
Purple?
might be upset. I'm gonna go ask Dr. Gray for a picture of his cats. I need proof that Cheeto looks like Cheeto and Oreo looks like Oreo. I heard from a friend.
You've never met Dr. Gray. You pull up and you're like, hey.
Can I see some cats?
I need
please?
Never. I don't know this man. Never interacted with him once in my life. But I know that he has cats named Cheeto and Oreo.
Do you have cats too, or just
No cats.
dogs?
Hugs.
It's just a pug.
Just
Just the
pugs.
pugs.
Okay.
Yeah.
Not just.
We used to have the Basset. He died. I don't know. Was that before any of
I think so.
y'all started?
I didn't know. Yeah, I didn't know you had a basset.
Yeah,
I
we
knew
had
about the
Bassett.
dogs.
Yeah, he died. It was in 2020, I guess.
Oh, so when
So
I
you
read
did
before.
know. Yeah.
When I
you-
got here.
They've been right
Yeah, it was right around then.
I used to have a basset.
Oh, I love Bassett.
He was a long-haired basset.
What?
Long-haired.
I wanna know what these.
He's
Sure,
a
it's a
long-haired
Basset.
Basset.
Yeah, he's a long-haired basset.
Okay, look this up. Then I want to talk about. Okay,
Okay,
can you
okay.
look that up? I gotta figure out what we're doing.
Yeah.
His name was Barkley.
Barkley.
We. Oh, that's.
Like this?
Kinda, yeah. Dude, I have whole ass pictures of him.
Yeah. Wait. How about we just get pictures of
Yeah.
your dog?
My fault, guys. That's on me. My bad.
Bassets are so. I love their ears.
Oh, they're the best.
I can't.
Oh,
They're so
He was-
cute.
he was my beautiful son.
Oh my god.
Let me see the long-haired Basset. Is that yours? Your long-haired?
He almost looks like
Oh,
And that's him
like a
with, like, a
beagle.
haircut.
Very beagle-esque.
he kind of
Yeah,
looks like
I
the dog
guess.
and Lady and the Tramp. The lady
Oh yeah.
with the
Oh,
with
yeah,
the longer
yeah.
hair. Do you know what I'm saying?
And that's him with a haircut. Like, his hair used to get, like, so long. But, yeah. Long-haired bassets are a thing, friends.
Okay, that's cool. You educated me on that.
Good. I'm
You
so glad I
learned
could be
him
of use to
today.
you.
Somebody had to.
Oh, okay. Are we?
That's fine.
Are we okay?
I
I
am
literally
just.
only live 20 minutes away. I just went to my dog's.
Yeah, I miss them all the time too. When we had to come back to doing this from COVID, I was so sad. I was heartbroken. I just wanted to stay home all the time, just because I can just get in a little pile with the dogs and Amy, and sometimes we're all in the bed together and we just.
I love when you put your
Close.
dogs on Zoom, or the one that sits behind you.
Hey, that's Maple.
I
Yeah,
love
yeah.
when you bring Maple up.
I love
Mabel
that
looks done with
she's
life, but-
willing- I love that she's willing to sit under a blanket.
Oh, constantly.
My
Yeah,
My
she's
dog does too.
constantly being bundled and swaddled.
Yeah.
Yeah.
My dogs, they have to be under the blanket. So if I'm sitting on a couch and I have a blanket on me, they literally like paw at me aggressively.
excuse
like,
me.
please put me under here.
Hello?
Yeah,
And they
yeah.
keep doing
Yeah,
it.
yeah, start digging on it.
Don't
Yeah.
you have fur?
I know. I was like, aren't you warm enough? And then they start overheating and they still won't get out from under the blanket. I
That's
said,
what
you
I-
need to leave.
Dude, something about a blanket. Dogs just get it.
This is gonna look a little swastika like.
Oh.
Yeah, I looked at it and I went, oh, I don't like
Oh,
that.
oh.
I don't like that.
I will not be
We
drawing
don't
this.
like it either.
In the most respectful
Um,
way possible, we are drawing these diagrams.
I mean, that
Wasn't there many
symbol
pictures?
wasn't always
Yeah.
Yeah, it
fucking
used to be,
hate-filled,
yeah.
like a
it used-
mystical, yeah.
Well, it's like integral to,
It's Hindu.
yeah, Hindu.
Yeah.
So I'm like,
Yeah. But it's
they were just really good at stealing things.
Oh,
Yeah.
absolutely.
Yeah.
But there we go, unfortunately, or fortunately, there we go.
It's
Yeah.
super
So what I'm doing is isoclines. So I set x dot equals 0, y dot equals 0. So I'm kind of following Strogatz's lead here. So this one is the x dot equals 0. This is the y dot
No
equals
clients.
0.
Okay.
Is that all making sense? What, did you know did you ask who Strogatz is?
No, I asked if it was isoclines or nullclines.
These are nullclines.
Okay.
Nullcline. So then here we have no horizontal change, so it's all vertical.
Yeah.
Like, those are wicked.
Yeah, this is kind of cool.
I was doing my homework yesterday afternoon. I plugged it in Desmos and I'm like, whoa. Wait.
I'm gonna be on an FBI.
Oh, you saw
watch list
this?
right now.
Yeah,
Yeah,
because I
yeah.
plugged it into Desmos and I was like, oh.
Whoa!
I'm not a fan of that.
Wow!
Trinity said cheese.
Oh,
Cheese.
Strong.
So then we need to get what direction these arrows are going. So check out over here, when x is positive and y is positive, let's see, we shouldn't have a sign change. So let's see, when x is positive and y is positive. Well, let's figure, okay,
Well.
here's what we're gonna do. So on this isocline here, where x dot equals 0, here's my equation.
Yes.
Y equals x minus x cubed. I'm going to look at y dot on this curve. So I'm going to plug this, I'm going to substitute this y and that y with x minus x cubed. So plug
Okay.
into the y dot equals. See what happens, just so I can see if it's where it's positive and negative. So I get y dot equals x plus x minus x cubed minus x minus x cubed. Cubed. And, this is x times x plus x minus x cubed times 1 plus 1 minus x minus x cubed squared. Ooh! You see that? You see that factor? I think that factorization is correct. I just pulled an x minus x cubed out of here and out of here.
Uh-huh.
And then this is the difference of two squares. So this is x plus x minus x cubed times y minus x cubed times 1 plus x minus x cubed. I don't know if any of that helps at all.
Minus x. Minus x.
What's that?
It's just a fun little algebra.
Yeah, just a little touch of the algebra.
Touch of it.
But I think this can probably help. Probably this form's more useful here because let's see. So when x is, this is 1. Oh, when x is between 0 and 1,
Uh-huh.
this is smaller than x.
Okay.
Fucking hell.
Yeah, me too.
So let's see, okay, let's just put in x equals a half.
Sure.
Let's see, so when x equals a half, I've got y dot, there we go. Just fucking, just do that. We get 1/2 plus 1/2 minus 1/8 minus, and then this is gonna be 1/2 minus 1/8 cubed. 8 cubed, 27
256.
things.
Thanks.
I think.
Is that 8?
I mean,
Yeah,
I'm
512.
talking shit. Damn it.
I was gonna take your word for
That was
it.
exactly
8
half.
cubed, 512.
Cubed?
I didn't come up with that.
And I said
I
256.
did not invent that.
Dang it.
I'm not
I
trying to
felt
one up
really
you and looked at
confident
it
about it
as
too. So
So this is clearly a positive quantity. Like all we give a shit about is it positive or negative, but like this is very small, this is very small, and this is 1.
So y dot is positive, and that's really all I needed. And then it becomes 0 here, so it must change sign. And I've got a feeling we could verify that this is like this. So we get a counterclockwise flow around the origin, if there truly is a circuit. And then, so here's what you need to do. You need to create a region around the origin where the flow is outward. So therein lies the rub, I think, really.
Love.
I almost kind of think like a diagonal like this might work good,
Love.
right? Like that, nice and simple. I think that if you did let's even try. Let's just see what how that might roll. So yeah, so that's going to be your inner circle. You want one where everything's flowing out, and then you need to put another one where everything's flowing in. Oh, no. Okay, here's what I would do. So step 1 is show that 0, 0 is a repeller, unstable, which should be pretty easy, and that tells you how the flow is out. And that means you can pick a little circle around it like he did, where everything is moving out. So can choose a small neighborhood about 0, 0, where flow is outward, but it's actually into your region. And then come up with an outer trapping region where the flow is in. And then 3 is construct. I don't honestly know what the best answer is here. We'll work on it together and chat. Construct the outer edge where flow is in. And then by Poincaré, Ben-Dixon, just because I get to say it one last time, we've got a limit cycle. I think it sounds kind of fun, exploratory. Yeah, and I would like Trinity's already got the direction field. That would help, I would think, just kind of like getting that, looking at that and getting some inspiration about what might work.
When does this homework due? Tentatively?
Let's do Friday. Let's do this Friday, because we're should almost be done, right?
Well, no.
Theoretically.
Is it okay if I bring it to you on Monday?
You can bring it to me. Yeah, let's just give it to me Monday.
Okay.
How about us just do it Monday? Start a class on Monday. It'd be great.
Okay.
Thanks.
Bye, besties.
Bye.
The only
Yes.
reason why I say that is because I will be